Well, okay, now we're on to the third question. So I wrote this down and I immediately thought triangle inequalities. So you've got the a plus b over here. You've got this triangle inequality and this triangle inequality. This bit matches up with the top of this fraction. This bit matches up with the bottom of this fraction. And these two over here match up with these. That corresponds with that, that corresponds with that. You get the gist. So what I was gonna do is first say that we know that a plus b is less than or equal to absolute value of a plus absolute value of b. And if that was our question and we didn't have these denominators of these fractions, then we'd be done. But we have the denominators. So then I was going to say, given that a plus b is greater than or equal to the absolute value of a minus the absolute value of b, all absolute valued, which is this second, is the reverse triangle inequality over here. Well, given that, oh, actually that's not a plus b. We're trying to put it in the context of the problem here. So that's c plus d. Right? And we get that from the reverse triangle inequality. So given that this c plus d is larger than this, I'm not going to explain, say it, but given that it's larger, if you divide a plus b by a larger number, then you're dividing this a plus b by, right? First, we know that absolute value of a plus b is less than absolute value of a plus absolute value of b. But on top of that, you're dividing it by a bigger number, so it's going to be even smaller. And you're dividing this by a smaller number, right? So, I don't know if deduce is the right word. It's probably not. Right, we can deduce that. And therefore, the absolute value of a plus b on c plus d is less than or equal to absolute value of a plus absolute value of b. I'll explain why you can just change absolute values on top of each other into this. So that's because if you have a fraction a on b, these aren't the same a's, by the way. Sorry, they're not the same variables, like that's not that a. So if you have a fraction a on b, and you take the absolute value of it, that's the same as the absolute value of a on the absolute value of b. Because in order to make a on b negative, you'd have to have a negative or b negative. You have to have one of them negative and one of them positive. But you're taking absolute value, right? So you can't have any of them negative. Yeah, I hope that makes sense. You can also write it as, that's the same as the absolute value of negative a and b. Yeah, which I hope you can see that the negative would either go to the negative a, like that, or the negative b, like that. You'd have either of those options, and then you cancel it out with the absolute value sign. Great explanation. That was amazing. Anyways, that's why you can do that, and that's kind of my proof. I thought it was too easy, and I think I'm being too vague. But now I'm gonna go check out the actual way to prove it from math sorcerer. So goodbye, and I'll see you when we get more problems.